if you don't know how to do electron configuration yet, you should go back and rewatch that video, because you're required to know how to do electron configurations before you can solve for valence electrons. Before we look at how to find the number of valence electrons, we are going to look at what they actually are. So the valence electrons are the outermost electrons. They're the electrons in the highest energy level. Now, we always say the valence electrons are the most important electrons in the atom in chemistry, because they account for the chemical properties of an element. Now, there can be a maximum of 8 valence electrons. So if you get more than 8, you did something wrong. And I say this every year, and then I always have multiple students that will put like 25 valence electrons on the test. So your answer, if I ask you how many valence electrons something has, you have 8 options, 1 through 8. And again, the valence electrons, if you think about it, they're the electrons on the outermost layer of the atom. So when two atoms collide, it's going to be the valence electrons that are interacting with each other. So the valence electrons of one atom will interact with the valence electrons on the other atom. They're the electrons that tend to come and go, and when it comes to reacting. So that's why they are the ones that are responsible for how a chemical reacts or how an element behaves. So that's why it's really important to know how to decide how many there are in an atom. So we'll practice. We got 3 elements. The first thing you should do is write the electron configurations for these. So I'll have you pause the video and write the electron configurations. Okay, now hopefully you're back and you have them. So double check, pause, check to make sure that your electron configuration matches for germanium. Now, to find the valence electrons, what you look at is these are the energy levels, these big numbers here. You look at all of those numbers. What is the highest number out of all of those numbers? If I look, I got 1, 2, 2, 3, 3, 4, 3, 4. So 4 is my highest number. So what I do is I look at this, and I look at this. Now I know that this 3d10 is in the middle. I don't care about it because it's in the 3rd energy level. So I'm looking at my 4th energy level, which is my highest energy level represented here. Now I see I have 2 electrons in the 4s sublevel, and I have 2 electrons in the 4p sublevel. Both those are in the 4th energy level, the highest energy level. So I take 2 plus 2. This element has 4 valence electrons. And that's how you solve for valence electrons. So now do cobalt, sodium, get the electron configurations. So here they are. Now what I would like you to do is pause the video and see if you can figure out how many valence electrons each of these has. So pause the video now. Okay, so hopefully you got an answer. Now, if I look, I got 1, 2, 2, 3, 3, 4, 3. So 4 is my highest energy level that is represented here. I ignore everything else. I don't even care that this is after the 4s. It doesn't matter. 4 is my highest energy level. There are 2 valence electrons in that highest energy level. So I have 2 valence electrons. Now sodium, I got 1, 2, 2, 3. Well, 3 is my highest energy level. So it's simple. I've got 1 electron there. I've got 1 valence electron. So sodium has 1 valence electron. So that's how you do valence electrons. We're going to take that now, and we're going to learn how to use those numbers to create the electron dot notation. So this shows the electrons in the highest energy level. So it takes your valence electrons, and it's a nice model to help us understand how bonding works. So when we come back to this, and I don't remember what chapter it is now, but we call them Lewis dot structures. It's a model that helps us understand how and why atoms bond, and what shapes they bond in, what shapes they make when they form their compounds. So we're just going to learn how to do the dot notation now, and then we're going to apply it in a couple chapters to make chemical bonds. So the steps. Step 1 is you find the valence electrons. Then step 2 is you put the dots around the element, and there's a particular pattern that I will show you. So there's a max of 8. So we're going to use this X. This X represents a random symbol. So we'll actually, if you had one valence electron, you'd take the dot and you'd put it right here. Now you can put this dot on the side, on the bottom, on the other side. I don't care where that dot goes, but you should have a single dot if you have one valence electron. Now if you have a second valence electron, it can go here, here, or here. Doesn't matter which spot, but it cannot go with this first electron. So we got two single dots. And you'll see what I mean in a second. The third one can go in the last two spots. So there's essentially four spots: top, bottom, left, right, that we fill up. So the third one can go here. The fourth one goes here. So these things kind of work like Hund's rule: single them up before you double them up. If you only have three valence electrons, they have to be in their own spot. You can't double them up yet. But remember, we can have a max of 8. So this is how you do the first 4. Now if you have more than 4, there's only 4 spots, so all 4 spots are full. So now we have to pick any one of these and double it up for our 5th electron. I could double up the top, I could double up the bottom. Doesn't matter how I arrange them, as long as I have a pair and 3 single dots around my atom. I could have my pair on this side and my 3 single dots here. The 6th electron goes here, 7th electron, and then the 8th electron would look like that. So if you have the maxed out number of valence electrons, it looks like you'll have 4 pairs: a pair on top, a pair on the side, a pair on the bottom, and a pair on the other side. So that's how you do it. So let's practice. If you write out the electron configuration of lithium, 1s2, 2s1, it has 1 valence electron. So what I would do is I'd take the symbol lithium and I'd put 1 valence electron. Again, doesn't matter where I put it. I could put it right here if I wanted. That would be the electron dot notation of lithium. The next one, chlorine. To save some time, I'm just going to tell you that this one has 7 valence electrons. So I take Cl and I go 1, 2, 3, 4. Just to show you, I could go like this: 5, 6, and 7. So that would be an example of chlorine. You could, if you wanted to, have your single dot on the top if you wanted. So you got 3 pairs and a single dot. So that's how you'd put 7 valence electrons on chlorine. And again, like lithium, it wouldn't matter if you went like that. Lithium could look like this. Doesn't matter as long as there's 1 single dot with the symbol. Neon. Neon has 8 valence electrons. So I write the symbol, and because it's 8, there's only really one way you can do this. It's the full set. So you double them up. First you single 4 up, then you double them up from there. So that would be neon. I got the symbol with 4 pairs of valence electrons around it. We're going to learn later that I call these the double dots and the single dots. The single dots like to form bonds. So like chlorine likes to form 1 bond, and the double dots don't form bonds. So that's what this is useful for. You don't know that yet necessarily. We'll practice that later in a future chapter. For now, you just need to know how to place the dots around the symbols.